Welcome back to Rational Equations Advanced Khan Academy tutorial. I decided to make a part 2 to this video just so you can see an example where you need to multiply by the least common multiple to both sides. So like any rational equation problem, what we're going to do first is we're going to start with a domain. So we know the domain is going to be all reals and there might be some exclusions, and we need to see what those exclusions are. To see what the exclusions domain are, we're going to take the denominator and we're going to set it equal to 0 and find what values for our variable make the denominator equal to 0. Why is that? Well, anytime you divide by 0, you get an undefined answer, and you can't have that as part of your domain. It's a gap. It's a hole in your equation where the equation cannot cross. So let's find out where that is. So we're going to say z squared plus 1, that's our denominator, and we're going to set it equal to 0. Now if you look here, there's no factoring z squared plus 1. It's not a difference of squares, and there's no such thing as sum of squares. So we're just going to go ahead and try to solve it. Get z by itself by subtracting 1 to both sides. We get z squared equals negative 1. Take the square root, and I hope you notice something here. So we get z equals the square root of negative 1. Well, that's an imaginary number. That's not part of the real number system. So there's no real numbers that make the denominator equal to 0. Therefore, our domain is simply all real numbers. So we don't need to worry about any exclusions here, which is kind of a good thing, because now we don't have to check our answer at the end, and we can just proceed to the next part, which is trying to solve for z. Okay, so what we're going to do here is we notice that our denominator is z squared plus 1, and we want to get rid of that z squared plus 1 in the denominator. We don't like that in the denominator, so we get rid of it. How do we get rid of it? Well, we're going to multiply both sides by z squared plus 1. Let me show you what happens when we do that. So first I'm going to write z, the left side, minus 57. I'm going to give some space here, and you're going to see why. Z squared plus 1 in the bottom, just like it was before. I'm going to put the z minus 57 in parentheses as well as the z squared plus 1. And I'm going to show you the distribution here of the z squared plus 1. So when you distribute the z squared plus 1 to the first term, you just multiply it in the top. Okay, let me put the equal sign. Equals, and we just have negative 1, and we're also going to multiply this by z squared plus 1. And there's no fraction here, so that makes it a little bit more simple. Now what happens? Well, I hope you notice that we have a z squared plus 1 in the bottom and in the top, so they can cancel completely. That's the whole point of distributing and multiplying by z squared plus 1, is so we could get rid of the base. Now we're just left with z minus 57 on the left side. Now we go to the right side. There's nothing to cancel, so we're just going to distribute the negative 1 to both these terms, and we get negative z squared minus 1. It looks like this is complicated, but since we have a z squared term, we have a z term, and then we have some number terms, we should get everything over to one side and set it equal to 0. I like it when the z squared is positive, so I'm going to go ahead and move this over by adding z squared to both sides. So I add z squared. Z squared plus z minus 57 equals negative 1. It's still not equal to 0. Remember, we need it to equal 0 so we can factor it. So I'm going to add 1 to both sides, add 1 to both sides. I get z squared plus z minus 56 now equals 0. Now I am ready to factor. So I'm going to put two parentheses here. This is just like our Chapter 5 practice. Some of you might need a refresher on Chapter 5. I should have some videos available on that, so be sure to check those out if you need some help with factoring. Now, I'm going to do a quick refresher. So this first term goes into the first slot, and the factors of the last term go into the second slot. So the first one's easy. What times what gives me z squared? Well, we should know that. I'm going to use pink. Z times z gives me z squared, and that one's easy. When there's no coefficient in front of z and it's just 1, it makes it pretty simple. Okay, so now we need to think of factors of negative 56. So one needs to be positive, one needs to be negative, that add up to give me a 1z, okay, a 1. So what are factors of negative 56 that add up to give me 1. Now, I've been doing this a while, so I'm pretty good at like thinking of what factors will add up to give me 1. And ones that come to mind is -8 and 7, and then +8 and -7. Okay, because I know 8 and 7 have a difference of 1, and now I need just to decide if it's going to be a -8 or a -7. Since it's a positive 1z, I know the bigger number needs to be positive. The positive team needs to win to beat the negative team. So I need to make the 8 positive, and I need to make the 7 negative. How do we know we did this correctly? Well, I'm going to show you how to check your answer. What you could do is you could FOIL. And just like you do normally with foiling, you could go first, inside, outside, last, and you could do the whole thing, but you don't really need to do that. In my opinion, you just need to check the inside terms and the outside terms. So the inside terms give us +8z. That's the inside. And the outside terms give us z times -7 gives us -7z. And we do 8z plus a -7z, you get +1z, or just z. So we know we did that correctly. Okay, let me clean this up a little bit so we can finish this up. So now we have it factored, which is very helpful for us. So we say z plus 8 can equal 0, or z minus 7 equals 0. We should be pretty good at this. We subtract 8 to both sides. We get z equals -8. Or add 7, we get z equals +7. So those are our two answers. Because the domain is all real, we don't have any exclusions, and we are ready to type this answer. So we have +7 and -8. +7, -8. There we go. Hope you enjoyed and hope you found this helpful.